Alright, welcome to homework takeout. We're doing section 2.4, page 280, number 9. So this question says, a club has 11 members. How many different two-member committees can the club form? So here we have 11 people to choose from. And what we can do is we can see that we can choose 11 people here for that first slot. And then for that second slot, we can have 10 people now because we have one less person because we've chosen that. So now here we can choose 11 times 10, which is going to be 110. Okay, but this is when order does not matter. Like if I choose person A, which is Albert, and person B, which is Brenda, if I have Albert and Brenda, I've chosen those two people. It's the same thing as having Brenda and Albert. So right here, this is counting too many things. This is a permutation. Right here, it doesn't matter who I choose first. So because order doesn't matter, you have to divide by 2 factorial. Because there's 2 different ways of doing that. So the answer for that is going to be 55. Because AB, selecting Albert first and Brenda second, is the same thing as Brenda first and Albert second. So you have to do that. Or you can choose it, you can write it this way. If you notice that this is choice, and as a combination, we can choose, right? You can just write it, you can write it just like this. 11, you have 11 members, choose 2, and you put that in your calculator, and out should pop out 55. So there's many different ways of doing this question, okay? If we do part B, we're just going to do the short way. In how many different ways can you form 3-member committees? So again, we have 11 members to choose from, and we're going to choose 3 people from there. And if we put that in a calculator, so you put 11 and then choose 3. Okay, I got 165, and that's the right answer for part B. Okay, let us do part C. I'm going to do it over here. In how many ways can a club president, treasurer, and secretary be chosen? So now you can't just choose any 3 people. So if I choose Albert here, which is going to be the president, and then we have a treasurer, and then we have a secretary. So if I have Albert, Brenda, and Calvin here, so if I have ABC for president, treasurer, and secretary, that's going to be different. This is going to be different if I have BAC, right? Because I've switched, Brenda is now president, and Albert is now treasurer, and C is still secretary. So in this case, for part C, because we're actually choosing specific titles, it actually matters. Order does matter in this case. So ABC is different than from BAC, which is different from these questions over here. AB is the same thing as BA. So in this case, you choose combinations. In part C, order does matter, so you use permutations. So there's a couple ways of doing permutations. For that first slot, we have 11 choices to choose from. And that second slot, now that we have we've already chosen one, we have 10 persons to choose from, and then we have 9. And so the answer to this would be 110 times 9. I can't do that in my head quickly. So 110 times 9 is going to be 990. Or you can write it this way. You have 11 permuting 3. So 11 permute 3 should give me the same thing. Yeah, 990. I just auto-zoomed there already. Okay, now let's do part D. And part D says, by what factor do the parts B and C differ? So we have part B here, and then we have part C here. Let's highlight this. So this is 165, and this is 990. By what factor? So factor means you're dividing out these 2 things together. So let's factor them out. So 990 divided by 165. Right? So what's the factor there? So 990 divided by 165 is actually 6. Okay? So what is it? They're asking, how do you account for this difference? What does this 6 actually mean? Okay. What this means is that over here, 11 choose 3. We're comparing, actually, sorry, let's do this again. We're comparing 11 choose 3 versus 11 permute 3. So what's the difference between a permutation and combination? That is really the only difference that they're asking for here, because we have the exact same number of people, 11 and 11, and in this case we're choosing 3, and in this case we're permuting 3. So the numbers are the same, it's just the concept's different. So you just have to remember that a combination is a special version of a permutation in which order does not matter. So if I were to take this 165, oh no, this 990, sorry, right? And what I'm going to be doing is we don't care what order these things are, because in combinations, in part B, it says we're just choosing any 3 members. So it doesn't matter what order they're in, they're all part of the community, they're all equal, right? All right, so what this means is that A, B, C, if we have person A, person B, and person C, this is going to be the same as A, C, B. This is going to be the same as B, A, C, and the same thing as B, C, A, and same thing as C, A, B, and C, B, A. These are the 6 combinations that don't matter. Okay? It matters for a permutation because the first situation is always president, treasurer, and secretary. So order matters in a permutation, but in a combination, it doesn't matter. So that's why we're going to divide out the 6. Or, if you want to take a look at this, this is 3 things, 3 factorial. If you do 3 factorial, which is 3 times 2 times 1, because you're ordering 3 different things, 3 times 2 times 1, that's 6. There's 6 different ways in which it doesn't really matter, which is why we're dividing them into groups of 6. So if you do 990, which is all the permutations, divide them into groups of 6, you're going to get all the combinations that are left over, which is 165, where order doesn't matter. Okay? I hope that's clear. If not, please email me or just contact us during the class. Okay? Good luck and thanks for listening to me.